Alright, in this video we will continue graphing rational functions such as these. So, I actually like to start with the slant asymptote or horizontal asymptote if there is one. So remember, there will be a slant asymptote only if the top degree is one more than the bottom. On this problem, that's what we have. The top degree is 2 and the bottom degree is this invisible 1. So because the top degree is one more than the bottom, most likely there will be a slant asymptote. The way you find the slant asymptote is by division. So I will do, you can do long division, which is what I did on the previous video. But in this case, a nice simple x plus 3, you can do synthetic division. So that's what I'm going to do. So synthetic division works like this. If I'm dividing by x plus 3, in the little box I put a negative 3. You know, it's what you get if you set this equal to 0 and solve. Anyway, now from the dividend, right, the numerator, the thing I'm dividing into, I need the coefficients. But be careful, there's a missing term here. X squared minus 1 is like having x squared plus 0x minus 1. So the coefficients are actually 1, 0, negative 1. So here I go, 1, 0, and negative 1. Oopsies. Okay, there's where my remainder goes. So here I go. I will bring down the 1. 1 times negative 3 is negative 3. Add these up, I get negative 3. Negative 3 times negative 3 is positive 9. That leaves a remainder of 8. We need there to be a remainder here if we're going to have a slant asymptote. But the slant asymptote just comes from this part right here. So the slant asymptote, if I put the x back in, it would go like here. So so see the x minus 3? So that's my slant asymptote will be y equals x minus 3. All right, notice how the 8 does not get involved in the slant asymptote. So I'm just going to put y equals x minus 3. So that's my slant asymptote. So I might as well go ahead and graph that thing. So if I want to graph this, I start at negative 3 and put a dot. The slope is 1 over 1. So that means I'm going to go up 1 over 1 like this. Then I'm going to continue that pattern backwards. Like this. So there's my slant asymptote right there. Now just for fun, you know, we really are supposed to draw a dotted line through this. So I am going to go ahead and do my responsibilities and draw that dotted line. Alright, so there's my slant asymptote. Okay, now I'm going to sort of work backwards and talk about the hole next. Is there a hole? Now a hole happens when there's a factor that cancels out in the numerator and the denominator. I'm going to erase this because it's in my way. So let's see, will there be a hole? If I factor the numerator, this is the difference of two squares. So I get x plus 1 times x minus 1. In the denominator, I have x plus 3. Nothing is going to cancel out. You know, if I had an x plus 3 up here and the x plus 3 is canceled out, that would be a hole. But since nothing cancels out, then there is no hole. So for the hole, I'm just going to put none. Alright, there is no hole. So now I can move on to vertical asymptote. It's important to sort of check for holes before you do the vertical asymptote, because if something cancels out, then it's not a vertical asymptote. It's a hole instead. But nothing canceled out. So now I can look for vertical asymptotes, and I know that when it comes to vertical asymptotes, I should be looking in the denominator. All right, here's where my vertical asymptote will come from. If I take this and set it equal to 0, if I take my x plus 3 and set it equal to 0, subtracting 3 from both sides gives me x equals -3. So that is the equation of my vertical asymptote. So I'm going to go ahead and draw a vertical line at -3 right here, and that will be my vertical asymptote. Okay, so I'll just do that quickly. So here we are at -3. Whoa. Okay, so there's my vertical asymptote as well as my slant asymptote. So we've done all that. So I might as well come down here now and talk about x-intercepts. So x-intercepts come from setting the numerator equal to 0, the zeros of the numerator. So that means I'm going to wind up setting each of these equal to 0. Okay, so if I set x plus 1 equal to 0, I get x equals -1. If I set x minus 1 equal to 0, I get x equals 1. So these are going to be my x-intercepts at -1 and 1. So that means, so when I say -1 and 1, I mean -1 comma something and 1 comma something. Now, since they're x-intercepts, that means they're on the x-axis. So the y value will be 0. So -1 comma 0 and 1 comma 0. So let's go ahead and plot those points. -1 comma 0, I've got a point there, and 1 comma 0 would be here. So right there, that sort of gives me an idea that my graph is probably going to dip below these points and go back up to approach the asymptotes. Okay, we've got all this, and so that's a good starting point. But now I need to plot a few more points to get a better picture of what's going on. Now I encourage you to plot as many points as you can. Let's see. So let's put the entire equation into the calculator. Okay, so we are ready to go. Now, I am in ask mode right now, which I highly recommend because it's good for fractions and decimals. Okay, it doesn't matter. Can I clear these out? It doesn't matter. All right, it doesn't matter what these are. I'm just going to type over them. So look, here's the deal. If I were you, I would pick a bunch of points and plot them. And anything we plot, we're going to record in a table. But the values that you guys tend to leave out are the decimals around the vertical asymptote. So the vertical asymptote is here at -3. I would definitely check the value at -3.5, just a little bit to the left, and -2.5, a little bit to the right of the vertical asymptote. All right, I'm mentioning those specifically because you guys usually skip them, and you should not. So I'm actually, you know what, I'm going to put my table here. Okay, so here are the values I'm going to do. So like I said, I'm definitely going to do -3.5, a little bit to the left. And I'll do -2.5, a little bit to the right. All right, and see what that is. I need a couple other points to the left, so I'll do -4 and -5. All right, I want at least 3 points on each side, so I'll do -4 and -5. Okay, so I've already got 3 points over here at that point. I'd like to see what's going on in between here maybe, so I think I'll check out what's going on at 0. Okay, so that's going to give me plenty of information. So let's plot these 5 points and see what we have. I already have a guess. Based on these 2 points right here, and the asymptotes of course, I think it's going to come from this asymptote, hit these 2 points, and go towards that asymptote. Based on that, I bet I'm going to have some points in here approaching the asymptotes on either side. All right, let's see how it looks. So I'll do negative 3.5 and negative 2.5. So negative 3.5. Okay, so that's negative 22.5. Okay, so that's like way, way, way off the graph. So not much I can do with that. You know what? Okay, so I'll still record it though on my little chart. So what was that? Negative 22.5. So now let's check negative 2.5. All right, that's 10.5. That's doable. So negative 2.5, I'm at 10.5. So that's off the graph, but just a bit off the graph. Okay, so negative 2.5, 10.5 would be like right there. Okay, let me record that. Okay, what about negative 4? Whoops, wrong button. All right, at negative 4, I've got negative 15. Okay, I'm still hitting the wrong button. Okay, negative 4, I'm at negative 15, which is still like way off the graph, so that's not going to be too useful. Wow, okay, so I feel like none of this is going to fit. So I might have to just stretch these lines out a little bit further and estimate. All right, so here's my estimate for negative 4, comma, negative 15. Okay, let's see, what else did I have? How about negative 5? All right, I really would like to have 3 points over here, but I'm having some trouble. Let's check out negative 5. At negative 5, I'm at negative 12, so that's a little bit better. Okay, so negative 5, this would be like negative 11, negative 12 would be about here. How about negative 6? All right, at negative 6, I'm at negative 11.6 or negative 11.7. So that's pretty close to this. All right, so I said I wanted 3 points. So, okay, so negative, it'll be about here. All right, I'm going to do one more. I mean, I've already got 3 points. I've got the idea. Let's take a look at negative 7. At negative 7, I'm back to negative 12 again. Okay, so that gives me the idea. That's enough points to show me what's going on. Okay, but I also wanted 0, didn't I? So I'm going to go ahead and put in 0 and see what happens. Okay, 0 is negative 1/3, and I know that's negative 0.3 repeating. Okay, so that's just a bit below the line. Okay, so that gives me an idea. So as I suspected, I'm going to have a curve going through right here, and I'm going to have a curve going through these points over here. So I'm just going to draw those in off screen. And there you go. This is what this graph should look like for, what is this, problem number 2? Your graph should look very much like this. All right, notice that this branch of the graph is completely off the graph. Every single point that I graphed was off of the grid. If that happens to you, go ahead and graph it. Just extend the asymptotes, plot the points as best you can, just estimate, and it'll be fine. But don't just skip it because it's off the graph.